This lecture in Module 6 is an overview of sustainable building strategies that are used commonly. This is meant to provide an overview of some of the strategies that you'll see in the readings, the rating systems, the videos that you are asked to watch for this module. We'll also look at some exemplary projects. On this particular exemplary project, the Candida building at Georgia Tech is actually a building that you will watch a video about. It's a great video, goes into really good detail about the way the building is designed and performs and many of the sustainable strategies within the building. It's important to note that this building was built by Skanska project managers and contractors, Miller Hull Architects, Interpogon Associates, landscape architects, and many, many different types of engineers. So, buildings like these are a collaboration, and very important that all of the consultants and the owners and the occupants come to the table early on to work on these buildings. So just a quick recap, we talked in the module overview about passive design. This is the most low-tech but effective way to achieve an energy efficient and zero energy or net positive energy building using the sun or excluding the sun and using cooling winds for natural ventilation. So when you use passive design strategies, building orientation is key. You need to orient the building, form, and openings to work with the sun and to also work with the prevailing winds when you want the prevailing winds. So of course you would block the winds in the winter and you would invite the winds in the summer. So you orient to summer winds. It's also important to do studies showing solar access to the building and design the overhangs and the pergolas and other shading devices in such a way that you exclude the summer sun and invite the winter sun. Additionally, placing trees around the building, you can do the same thing. So here's an example of a building. This is the Dixon Water Foundation Josie Pavilion by Lake Flato Architects in Decatur, Texas, a very hot, dry climate, but a climate with a lot of winds. And so the building is designed to open up to the winds, to exclude the penetrating sun with very deep overhangs, but to invite the winds and to open walls where appropriate, and to allow the users of the building and the people who are running the building to modify their own environment, which is a huge sort of fundamental shift in the way people think about buildings. You think about an office building, you can never open the windows, you can never turn down the heat or turn up the heat, but sustainable buildings do allow the users to control their own environment. And because of course, people in the space know what's most comfortable for themselves. So passive strategies include ventilation by opening walls and pivoting doors, moving louvers, and then even having a cupola on the rooftop that allows for the heat that enters the building and rises to be ventilated out the top. The cupola also does double duty for daylight in the building. It allows daylight penetration into the spaces. Now the active systems, the mechanically operated systems, are the ceiling fans and the photovoltaic panels that are mounted on the south-facing roof. So a good net zero energy building will use both passive and active strategies to achieve net zero. Another passive design strategy, besides using the sun and the wind and orienting the building to take advantage of these, is to optimize the building envelope. In other words, insulate the building very well with insulation that's appropriate to that climate, that keeps the cool air in the summer and excludes the hot air, and vice versa in the winter. Also using very, very efficient windows, double or triple pane windows that keep the summer heat out by reflecting heat out, keep the winter heat inside the building, allow for visible light, but reflect UV light, and provide some insulation value as well. Other methods of tight construction, construction that doesn't allow much air penetration. And then lastly, cool roofs. And the building on the bottom is the Los Angeles Museum of the Holocaust by Belzberg Architects in LA. It's utilizing a green roof, which is one of the coolest roofs you can put on a building because the vegetation keeps the roof surface very cool, but it also, the soil and the vegetation adds quite a bit of insulation to the roof of a building. Active design is primarily renewable energy on site or the building, but it's also designing a building with very efficient heating and cooling systems and other mechanical systems that move air around. The Candida building at Georgia Tech is a net positive energy building in that it produces more energy than it needs from a rooftop that is almost all solar panels. These solar panels are canted to be directly perpendicular to the sun at its highest point in the sky to maximize solar gain. I'll give you a minute to think about a passive strategy that these solar panel rooftops are providing. If you were thinking to yourself, they're providing shading in the summer, you would be right. So net zero water is another sustainable architecture strategy. This is back at the Dixon Water Foundation project, where rainwater that falls on the rooftops is captured and held in cisterns. It's used to for non-potable uses, such as sewage conveyance and irrigation needs. Gray water from the sinks and black water from the toilets is transferred to storage tanks and cleaned slightly before it gets circulated through a wetland on site, which you can see here. And eventually it gets returned to the soil and eventually back into the aquifer. So it's kind of a closed loop system in that water is drawn into the building from a well, which comes from the aquifer and gets used for potable uses in the building. So it's a closed loop system that also incorporates some composting toilets as well. Healthy indoor air quality and ventilation is key. This means that one needs to be able to open windows and walls, use healthy building materials, and use healthy cleaning products. We already talked about that in the module overview. Just a reminder that this is the Living Building Challenge red list of materials. This has been transformative in the building industry because all of a sudden product manufacturers are making sure that their products don't contain any of these chemicals or constituents, and it's really transformed the building industry. So for instance, people are moving away from chlorinated polymers, including PVC. People are moving away from formaldehyde, PFCs, phthalates, and then of course, toxic heavy metals like arsenic, cadmium, chromium, lead, and mercury. Probably the biggest change is that people are moving away from finishes like paints and stains and adhesives that contain VOCs. So this has really been transformative to the building industry. Even though not a lot of projects engage in the Living Building Challenge, product manufacturers are really trying to design their product to work with the Living Building Challenge. Low carbon materials is another aspect of sustainable buildings. The easiest low carbon materials are those that are local because they don't require much of a carbon footprint to transport them. Minimally processed materials are also low carbon. Wood is a really low carbon material because it's minimally processed as compared with metals and plastics and concrete. But also it sequesters carbon until it decomposes. So even a piece of lumber in a building sequesters carbon until it either burns or decomposes. Low energy materials are also good. Some bio-based materials are considered to be low energy materials. The ones that are higher energy are concrete, metals, and plastics. But concrete's carbon footprint can be substantially improved through use of recycled content and particularly through cement substitutions. Some industrial byproducts are good cement substitutions. And then of course the footprint of metals can be substantially reduced when you use higher recycled content, as we talked about in module 5. Low resource use building materials also contribute to sustainable buildings. Remember our waste hierarchy that we talked about in module 5. Reused structures would be at the top of the waste hierarchy because they're whole structures that are being reused. These structures that you see in the images are the box yard, which is located at Research Triangle Park. It's a retail and restaurant and event space that is constructed from shipping containers. There are millions of shipping containers in this world that have been abandoned and are being incorporated into houses and other types of buildings. Unfortunately, there's also some shipping container houses that are being made from new shipping containers, which actually defeats the purpose of calling them sustainable structures. Further down in the waste hierarchy is reclaimed materials, then minimally processed materials, then recycled content materials. But remember, when you have recycled content materials, they are hard themselves to recycle. So that's sort of lower down in the waste hierarchy. Daylight and views are very important for sustainable buildings. This is another diagram showing the penetration of the winter sun into buildings. One wants the winter sun to come directly into buildings to bring heat with it. But one way to get winter sun deeper into a building is to use a light shelf, which is what's shown here, where the sun hits the light shelf, bounces off the ceiling, and then bounces farther into the space. You also can get ambient daylight into a space, but it doesn't bounce as far into the space because it's not direct light. The general rule of thumb is that 40-foot wide floor plate, in other words, a 40-foot wide building, is about as wide as you can go if you want to have daylighting in the spaces. In the summer sun, of course, we don't want the heat to come in, but we can use light shelves to bounce light in. And we may actually have to use more electric lights in the summer because we don't want the heat of the sun to penetrate the building. So a combination of daylight in the building through use of direct light and light shelves, and then shading when we want it, makes for a very healthy and happy building occupant. Additionally, views to vegetation are important, and you will be watching the film about biophilic design. In addition to bringing plants into the buildings and next to buildings, it's really important for building occupants to be able to look out of buildings and see plants. And this can happen in the most urban of settings, but we just need to get more vegetation into our urban settings. So the biophilic environment talks about humans' innate attraction to nature and natural processes. So any design that brings nature, plants, et cetera, into the building, or allows for building occupants to go outside right next to the building and have access to nature is a good thing. These images are both ETSI headquarters by Gensler Associates. This is a Living Building Challenge project as well. So we want to minimize the building footprint. You know, sites that have a sprawling one-story building on it use up a lot of a site and destroy a lot of habitat. So whatever square footage we need, it's better to make that square footage happen in multiple stories, 2, 3, 4 stories, and protect as much of a site as we can. Building more compact buildings, of course, does that, as well as saving on resources. We don't need a 4,000 square foot house when we could all live very comfortably in a 2,000 square foot house. Smaller parking lots, shared parking is another way to minimize the building and site footprint. And then of course, shared driveways. We talked about this in module 2, keeping water on the site near where it falls. Employing green infrastructure strategies is a good way to deal with stormwater and keep the site healthy. One can do this with green roofs, with bioretention areas, with rain gardens, which are basically bioretention areas, but smaller, and with water harvesting. In this case, this is the Germantown Friends School. They are doing all of this in order to keep water on the site and reuse water where appropriate. Habitat protection and restoration is also part of a sustainable building and site. This is the Sonoran Landscape Lab at the University of Arizona. This is a natural resources building, and believe it or not, this is a very, very urban campus. But Tenike Associates, landscape architects, provided habitat that is appropriate to this desert biome. Some qualities of good habitat are that there are multiple species. There's cover for wildlife. There's water for wildlife. The species are native species. That's the most appropriate to wildlife, to support wildlife. And the soils are healthy and restored if necessary. So appropriate vegetation, of course, is almost always native vegetation, but where you can't do native vegetation, one should avoid invasives. And you would be surprised how many nurseries actually sell invasives, but they do. And then if native can't be used, low input vegetation is appropriate. Sometimes that's called adapted vegetation. This is vegetation that is appropriate to the climate. So you don't need water, except just to establish it in the first year. But after that, you don't need water. You don't need fertilizer, and you don't need pesticide. The image on the top is a green roof, actually. SUNY ESF Gateway Center green roof, and the image on the bottom is the Phipps Conservatory in Philadelphia, both by Andrew Kogon Associates. Food production is an important aspect of sustainable architecture. It might be food grown on the roof of a building. Brooklyn Grange is a very famous rooftop garden in Brooklyn, New York, very fruitful, literally. And then the image on the bottom is Thammasat University in Bangkok, Thailand, where food production is actually used as the ornamental landscape. And it's a great way to kind of get extra bang for your buck out of the landscape. Additionally, there's agriculture in some buildings. So this has just been a very short overview of some of the sustainable strategies for buildings, but I encourage you to go on the 2030 Palette website and look at the building section for all of the strategies that one can employ to create sustainable buildings. I think it's a really great website, and you can click on the image. It'll tell you about the strategy. It'll give you some example projects. It'll give you some more detail about the strategies. Thank you.